Hello again and welcome back to our course on Excel 2019 Advanced. In the preceding section, we looked at some averages in relation to statistical samples, and in this section, we're going to look at measures of spread. Now, in order to do an analysis of a statistical sample, or indeed to do a comparison with another statistical sample, it's pretty much always necessary not only to have some kind of averages to give you an idea of how big or how long or how many of something are associated with that sample, but also to have a good idea as to how spread out the values are. How much variation is there in this sample? Now, in statistics in general, there are quite a few very useful measures of spread, and we're going to look at the main ones in this section, and we are going to look at alternatives for calculating them in Excel 2019. Now, as part of that, I'm going to need to explain one or two statistical concepts and terms, but I'm going to do that in a pretty straightforward way. So if you're not too comfortable with statistics, I think you should still have a pretty good idea of what's going on in this section. So what I've done already is to calculate the median number of inquiries and policies, and you may recall that the way that we calculate the median is that we put the number of inquiries per month in numerical order and we look for the one that is in the middle. If there are two in the middle, so we've got an even size sample, we take the average of the middle two. Now, if you did that with the contents of column B, so we're talking B4 downwards, you would find out that the median is 574. But of course, we use the median function in Excel 2019 to do that for us. Now, I also mentioned that apart from taking that middle value, we could identify the quartiles, and the quartiles lead us to a very good measure of spread. So what I'm going to do now is calculate the quartiles for the number of inquiries and the number of policies. I also mentioned earlier on that there are actually two quartile functions, quartile.inc and quartile.exc. And in a moment, I'm going to explain the difference between them. But for the moment, let's just calculate the quartiles, and we're going to start with the quartile.inc function. And my array will be branch inquiries. And we get 418. All I need to do then for the first quartile is repeat that, identify the same name for the range of inquiry values, and change the quartile number to 1, and so on. So I'll do that next, and let's see where we get to. So there are 5 quartile values. If we put our inquiries in sequence, the first 25%, the smallest 25%, will be between the 0 and first quartiles, between 418 and 493, etc. Now, the quartiles are very commonly used in statistics, and the measure of spreads that we can derive from there is called the interquartile range, and we calculate it as the difference between the first quartile and the third quartile. There is an additional measure of spread that is called the semi-interquartile range, that is half of the interquartile range. So I'm going to calculate the interquartile range and the semi-interquartile range. And I'm also going to put in the quartiles for policies. Now, of course, when you open this file in the course files folder, you'll see all of these formulae and so on. But at this point in this section, you may want to try these out for yourself. So having completed those calculations, including the quartiles for policies, I've also calculated the interquartile range and the semi-interquartile range for policy sales. And if you've been working along with this, you should have come up with the same figures as the ones that I've got here. So the use of these ranges is pretty popular in statistics, and I'm going to come back to those a little bit later in this section. Before I move on to talk about what is probably the most important measure in spread, I want to take a moment to talk about INC and EXC, as I said I would. So within the Policy Sales Workbook, I've included a worksheet called Inc.Exc Demo, and this is a very straightforward demo of the difference between Inc and Exc. The data that we're finding the quartiles of are in B2 to I2, so the smallest number is 23, and then in rows 4 and 5, I've got the quartiles calculated using quartile.inc and quartile.exc. The most notable thing is that if you use quartile.exc, so for example that the formula in cell C5, the quartile value of 0 is actually invalid. There isn't a 0th quartile this way. There isn't a 4th quartile this way either. And in fact, the remaining values and remaining quartiles are calculated in such a way that although the median is the same as with the quartile.inc, generally speaking, the first quartile and the third quartile will be smaller and larger respectively, and therefore will give a larger interquartile range. Now, I'm not going to go into the reasons for all of these differences. In fact, there are many other ways of calculating quartiles, but there are a couple of pretty good explanations of how these two methods work. And if you search the web, there are a number of papers that discuss the differences between the two of these. Now, during the rest of this course, when I need to use quartiles, I tend to use quartile.inc, and that's what I will be using going forward throughout this course. Now, the quartiles, the interquartile range, etc., are very important in descriptive statistics. Not only are we wanting to describe a sample, but we're wanting to use the values in the sample to perhaps predict what's going to happen in the future, maybe to calculate some properties of the population that we've sampled from, or maybe to infer something else from that sample. And in order to do that, there is an even more important measure of spread, and that's called standard deviation. And there is also an associated measure of spread, that's the square of standard deviation, and that's called the variance. Now in this section, I'm going to concentrate on calculating standard deviation. And just to confuse matters a little, when you want to calculate standard deviation, there are really two options, and it's very important to understand the difference between them. If I take a sample such as the number of inquiries over several months in this branch, and I work out the standard deviation of this number of inquiries, which is a measure of how much the number varies, then I can either calculate that standard deviation as the standard deviation of the sample, or I can calculate it in such a way that I'm trying to estimate the standard deviation of the population that the sample has come from. So let's suppose you were working on a production line in a factory and you were measuring the length of objects you were making or the weight of objects you were making. If you say took 10 products off of that production line, you might either say, what's the standard deviation? How much do these vary? Or you might say, using the values from these 10, what's my estimate of the amount of variation in the underlying population? Now, using the correct one of these from a statistical point of view is very important. And in Excel 2019, there is a function for each. If you wanted to find the standard deviation of a sample itself, the function you use is stdev.p, and all you would need to do in this case is specify the name of the range, so that would be branch inquiries. So let's do that. And now we just need to specify our named range, and we know it's branch inquiries. I'm going to show you a little extra tip on how to bring up those named ranges. If you press your F3 key, it will bring up any named ranges you have in the workbook. So let's select branch inquiries. And there we go. Let's take those decimal places down. So that's the standard deviation. If, on the other hand, I want to calculate this standard deviation and use it as an estimate of the population standard deviation, I use a slightly different function, and that is stdev.s. So let's try that. And again, F3. branch inquiries, and let's roll those decimal places down again. And I'm going to do the same for policies. Let's now take a look at a specific example of how we might use these descriptive statistics. I now have two sets of sales figures. The first set, columns B and C, are for the Orlando branch, and the second set, columns D and E, are for the Tampa branch. And for each case, I have details of the number of inquiries and the number of policies as before. And if you quickly glance down the list, you definitely get an idea that Orlando does a lot more business than Tampa. But it would be very helpful to be able to actually put some solid figures or some solid evidence together about the difference in the amount of business they do. So what I'm going to do is calculate the mean over the allotted period for both branches, and I'm also going to work out the standard deviation and the interquartile range. And here you can see the results of these various calculations. I would suggest that you take a look at Policy Sales 5. Make sure you're familiar with the formulae that are in use here. If you really wanted to do an analysis of one of the branch's results, and in particular if you wanted to compare the two branches, there are various statistical techniques that you could apply, but just at a very superficial level, if you look at the mean values, for example, generally speaking, on average, Orlando has about twice as many inquiries and twice as many policies issued as Tampa. Having said that, whereas with Orlando the number of inquiries compared to Tampa is well over twice, the number of policies is less than twice as many as Tampa, which sort of implies that Tampa, although it's a branch dealing with less inquiries and less policies, they seem to be more successful at turning their inquiries into policies. The other thing to note is that if you look at the level of spread in the case of standard deviation for inquiries for Orlando, it's 64.5, whereas with Tampa, it's 49.25. And given that for inquiries, there are well over twice as many inquiries in Orlando than there are in Tampa, there seems to be, relatively speaking, more of a spread in Tampa inquiries compared to the actual number of inquiries. The same is true of policies as well. It's also interesting to compare figures like the semi-interquartile range, in each case with the standard deviation, although as I mentioned earlier on in the section, in terms of formal statistical analysis, standard deviation is a measure of spread that is used more frequently than interquartile range or semi-interquartile range. So that's it on the use of statistical functions for description. In the next section, we're going to look at forecasting, so please join me for that.